Index iteration. So far, we have iterated through a list using the for each syntax to get each value of the list. We've also used indexing to access specific values in a list by their individual position. In many languages, indexes are used to iterate through all the values of a list. The index of the list are the integers, starting from 0 and counting up, that uniquely identify each element. The code shown here demonstrates how we can access indexes using positive and negative integers. In this chapter, we'll learn how we can use indexes to iterate through the list, modify elements of the list, and do more complex manipulations to the list. The top code shown here is the usual way to process a list in Python, where we iterate through each value. However, you can also iterate by using a combination of the range and len functions as shown here. Both the value style and the index style shown will print the same result. The index style is a little more complicated, since we need to use the two helper functions. So let's take a closer look at them. The len function is relatively straightforward. The function consumes an iterable like a list and produces an integer representing the length of a list. In other words, the number of elements in the list. The len function also works on strings, producing the number of characters in the string. In fact, the len function does all the work of the basic count pattern, although sometimes you want to extend that pattern in ways that you cannot with the len function. The range function consumes an integer and produces a list of integers from 0 up until that number. One use case is to iterate an explicit number of times, as in the first example, where we iterate exactly 3 times. A distinct use case for this is to create lists of numbers via the map pattern, as shown in the second half of this code. In that example, we iterate 10 times in order to produce a list of 10 numbers, starting from chapter 0 to chapter 9. As an alternative to combining range and len, we can also use the enumerate function. The enumerate function allows us to access both the values and indexes at the same time. While convenient, we do have a new, unusual feature to learn about. Instead of one iteration variable, we now have 2 iteration variables to worry about. This only works because the enumerate function returns a list of pairs of things. So far, we have focused on only one way to modify a list, using the append and pop methods to add and remove elements from the end of the list. But we can actually also update the elements of a list using assignment statements, similar to how we can update fields of a data class. As the example code illustrates, we just put the indexed element on the left-hand side of the assignment statement, and the appropriate index values will be changed. Note also that the first commented out block of code demonstrates that we cannot use this to add new elements to the list. If you attempt to update an index outside of the size of the list, you'll get an index error. Note also the last example shown in the commented out code, where we try to first character of a string. That does not work and will cause an error because strings are immutable. Up until now, our for loops have always created new lists instead of directly modifying old lists. This is because modifying values makes it difficult to keep track of changes. But sometimes we will want to modify every element of our original list. By combining the enumerate function and the index assignment syntax we just learned, we can do so. This code shown here will add the letter S to the end of each word in the original list, and then assign to that index in the list. Sometimes you will need to swap the position of 2 elements in a list. In order to do so, we need to assign directly to multiple indices at once. This is similar to how we can assign to 2 iteration variables at once when we use the enumerate function. Python always handles the right-hand side of the assignment statement first, so the original values are obtained and put into a new list. Then, those values are assigned one at a time to the 2 entries on the left-hand side, which are the first and second indexes of the list. By assigning to the index, we update the values stored at that location. So when do you use indexes and when do you use values? Usually, you should stick to value style unless you have an explicit reason to use indexes. Indexes allow more flexibility and are necessary for certain kinds of specialized algorithms. However, They require more operations and are more complex to reason about. When you manipulate indexes, you run the risks of mutable danger, which we discussed a few chapters ago. In general, we prefer to read data and create new values instead of modifying existing values. That way, we don't have to keep track of whether data has changed later in the program.